Section 6.7 talks about derivative of logarithmic functions, and it's kind of straightforward really. Derivative of a log of an argument is 1 over the argument by the chain rule times the derivative of the argument. Very simple. If I'm taking the log of the derivative of not a natural log, again remember, natural log is a log with base e. If the base is not e, anything other than e, then I could use the change of base formula and say that's natural log of x over natural log of e, natural log of a. Natural log of a is a constant. I could ignore that and end up just taking the derivative of natural log, which is derivative of natural log of x is 1 over x. I'm sorry, I made a mistake. Please note that derivative of natural log of u is 1 over u. All throughout this section and all throughout the course, that's what it is. I had 1 over natural log of u, that was a typo. So please make a note of that. So that's going to give me a lot of leeway when I take a derivative to avoid many unpleasant rules, such as I could say the derivative is 1 over 7x times the derivative of the argument, which is 7, and that reduces to 1 over x. That's one way. Another way of doing this same problem, you could say, you know what, this is natural log of 7 minus natural log of x. When you take a derivative, that's a 0 minus derivative of a natural log of an argument is 1 over the argument, and there it is. Except the previous one, oh, I'm sorry, that's a plus, not a minus. Right, the product rule? The product rule of the first law of logs. So how do you want to do this? It's up to you. I suggest you make use of this whenever the time arises. Again, I'm going to do the first few problems both ways. You could say dy dx is 1 over the argument times derivative of the argument, which is 5x to the 4th. And if you reduce that, you would notice that that is actually 5 over x. Another way of doing this problem is for you to say, you know what? I can take this by the third law of logs and say, oops, I put it in the wrong spot. I'm getting excited there. Say y equal 5 times the natural log of x. And when you take a derivative, 5 is a constant. Derivative of natural log of x is 1 over x. And there it is. So that's what I'm going to really do with those. Here, derivative of a natural log is 1 over the argument times derivative of secant, which is secant of x tan of x. And I notice they cancel out. And that would be the tangent of x. We are making the assumption here that this is always bigger than 0 and not equal to 1. I'm always positive. So again, secant could be negative. We're making all the assumptions. Assume all of this theory hold. Same thing with tangent. Tangent could be negative. Assume we're only looking at certain x in which this is always positive. And when I take a derivative, 1 over the argument, derivative of tangent is secant squared of x. On a test, this is sufficient. That's all I want. For the homework, you might have to clean it up a bit. This is a cotangent, which is cosine of x over sine of x. And this is 1 over cosine squared of x. So the book probably will do that. For the homework, you might have to do something like that. One of these cancel out, and what's 1 over sine of x cosine of x. That's good enough. The book might even write that as cosecant of x, secant of x. All of that is the same to me. As long as you could do the calculus, we're in good shape. The cleaning up will come up as we proceed. If I look at this part E, I have a couple of options, and I'm going to make use of these options. Instead of using the quotient rule, it would be much easier to just write that as the difference by using the second law of logs no calculus yet. And that's why we spend time on properties of logs. It really makes life a lot easier. That's a 0. 1/3 is a constant. Derivative of natural log of x is 1 over x, and there's my answer. Again, I could avoid the quotient rule here by saying y equals 5 natural log of x minus 2 minus natural log of x plus 3. Y prime would be 5 times. Derivative of natural log is 1 over the argument. Derivative of x minus 2 is really 1. And 1 over x plus 3. And you could leave your answer like that, not a problem. I noticed the base is not an e. Well, I know by the change of base formula I could write that as a natural log of the sine of x over natural log of 3. So when I take a derivative, 1 over natural log of 3 is a constant. I ignore that. Derivative of a natural log is 1 over the argument times the derivative of sine, which is cosine of x. And again, on a test, this is sufficient. Most likely, in the back of the book, they'll say, well, hey, you guys, come on. Cosine over sine is the cotangent of x. So either of those will be accepted. And if I look at the next problem, again, instead of dealing with all of these rules, logs allow me, and there's a warning I'm going to give you, properties of logs. So if I take dy dx twice, derivative of natural log is 1 over the argument, times derivative of cotangent, which is cosecant squared of x with a minus. This is sufficient. You could clean that up to match it with the back of the book on the homework for the test. That's good enough. And here, well, we have the product rule. dy dx would be product rule, derivative of the first times the second, plus the first derivative of natural log is 1 over the cosecant of x times negative cosecant of x cotan of x. And here I would want to clean that up a bit. That is 3x squared natural log of cosecant of x minus x cubed times cotangent of x. And there it is. And here I need to use the quotient rule. Y prime would be derivative of the top is 1 over x times the denominator minus the top times derivative of the denominator all over the denominator squared. And if I clean that up, this is a complex fraction. LCD is x, so that's going to be sine of x minus x natural log of x cosine of x all over x times the sine squared of x. Complex fraction came up in the previous course a lot more than you like. And that's pretty much it. That's all there is. The warning I want to give you a note. I'm going to put it right there. If you have natural log of x squared, that does not equal twice natural log of x. Be careful not to mix that with natural log of x squared is twice natural log of x. So the point is, if the argument is being squared, I could move that 2 up front. But if the entire log is being squared, I can't move that up front. That's not really the third law of logs. And that's pretty much it for this section.